Hello everyone, we're still in Module 6B, the iterative methods in linear algebra. We have just finished discussing yung Jacobi method sa previous content. This time, we'll just expand our knowledge or extend what we know to the Gauss-Seidel method and your SOR method. So how do we apply these? Start na natin. Okay. Sa Gauss-Seidel method, it's actually also called as the Liebman method or the method of successive displacement. Actually, sobrang similar lang siya sa Jacobi method, yung application niya. However, di ba, if you recall from Jacobi method or yung method of total steps, na nanggagaling lahat ng uh, values na sinasubstitute natin sa current iteration from the previous iterations, this time, gumagamit na rin ng recently computed values ng x. Okay, meaning, may parts ng equation natin na isasubstitute natin yung uh, value or yung guess natin for the variable x at the current iteration or during the same iteration. Okay, so you'll see how we do this sa ating example. But for now, ganun yung main difference between Jacobi and Gauss-Seidel method. Okay, again, this should be applied as long as yung diagonal natin is non-zero. And syempre, dapat yung matrix A natin is uh, also diagonally dominant. Okay? So, bakit nga ba ginagamit natin yung most recently computed values na rin ng x sub I? Para mas maging mabilis or we expect a faster convergence sa ating approximate solutions. So, dahil nga doon, it's also called an iteration by single steps. Okay? And ito yung equation. Sobrang similar lang talaga niya with the Jacobi method. The difference lang is we have two summations na dito. Parang pinaghiwalay lang yung summation from the Jacobi. Yung isa using the previous iterations, yung pangalawa using the current iterations. Diba? May k dito and k plus 1. Okay? Right? So, just like what we have done kay Jacobi method, pwede rin isulat itong equation na to sa ganitong form. Okay? Which represents, in which yung second part or second equation sa right hand side, second term, represents the residual. Ibig sabihin, it approaches zero kapag mas lumalapit sa solution yung variable x natin. Okay? So, this is a sample algorithm on how to apply yung ating Gauss-Seidel method. Pero, syempre, you can also design your own para mas madali nyo magets. Now, we also apply yung Gauss-Seidel method din sa same example natin kanina from the Jacobi method. Okay? So, first step always is to ensure na diagonally dominant yung matrix A natin. Yung matrix ng ating coefficients. Okay, as you can see here, 4 ito, 1 ito, tapos 1 din ito. Diba? From there pa lang, hindi na diagonally dominant. So, what we can do is to exchange itong second and third equation para yung 6 malipat dito and yung 7 malipat dito. Okay, so ito na yung bago nating uh, arrangement. So, in-arrange lang natin para ma-ensure natin yung convergence ng ating iterative method. Okay, so 4 na to, 6 na to, and 7 yung elements ng ating diagonal. Okay, so just like what we've done sa Jacobi method, we simply get an expression for x sub 1 from the first row, x sub 2 from the second row, and x sub 3 from the third row. Okay, isolate mo lang. So, yan pa rin naman nakuha natin from the Jacobi method kanina. The only difference here, di ba, as you can see, may blue and orange na highlights dito. Okay, just like what I've said kanina, may parts kasi na manggagaling na sa current iteration yung value ng x natin. Sa case na to is yung orange. Okay, okay, unahin natin dito. As you can see, parehong blue yan kasi wala pa namang current value sa x sub 2 and x sub 3 kasi ang natin sinosolve sa bawat iteration is x sub 1. Okay, so hindi pa natin alam sa x sub 2 and x sub 3 sa current iteration. So, ang pwede lang natin gamitin for this is yung values niya from the previous iteration. Okay, or for example, first iteration ito, gagamitin natin values na x sub 2 and x sub 3 are our initial guesses. Okay, so okay na yan. So, for x sub 2, as you can see, naka-orange na sa x sub 1. Bakit? Kasi we have already previously solved yung value ng x sub 1 sa current iteration. So, pwede natin i-apply yun. However, sa x sub 3, naka-blue pa rin kasi wala pa namang value sa x sub 3 sa current iteration. So, gamitin pa rin natin yung value niya from the previous iteration. Okay, and finally, kay x sub 3, x sub 1 and x sub 2 na yan. And since sa first two equations natin, nakakuha na tayo ng current values nila, pwede natin i-apply yun to these equation. Okay? So, nanggaling lang din naman yan from here. Okay, ito lang yung uh, equation niya using summations. Okay? So, let's just copy these equations, 1, 2, and 3, and create the table of values. Okay, for our first iteration, we again apply or use some initial guesses. Let's say 0, 0, 0 ulit. Okay? And for the first iteration, since wala pa namang current values sa x sub 2 and x sub 3, ito yung gagamitin pa rin natin to substitute here. Okay, so we have 3 plus 0 plus 0, that's 4, divided by 4, that's still 3/4 or 0.75. However, since meron na tayong current value na x sub 1, okay, pwede na natin siyang gamitin sa calculation kay x sub 2. So that this becomes 9 plus 2 times 0.75 minus 0 pa rin kasi wala pang current value si x sub 3. So that's 9 plus 1.5, so 10.5 divided by 6, we have 1.75. Okay, pero kay x sub 3, since pareho nang may current value si x sub 1 and x sub 2 sa current iteration, yun ay substitute natin. Negative 6 plus 0.75 minus 1.75. So that's 6, negative 6 minus 1. It's negative 7 over 7, you get negative 1. And again, kunin lang natin yung absolute error between the previous and current values of our x variables. So 0.75, 1.75, 1. Okay, so sa second iteration, since wala pa tayong current value for x sub 2 and x sub 3, ang gagaling nito sa previous. So 3 plus 1.75 minus 1. So that's 3.75 over 4. That's 0.93750. Okay? Yan ngayon yung pwede na natin i-apply dito kay x sub 2. Pero sa x sub 3, yan pa rin dito kay previous. So we have 9 plus 2 times 0.93750 minus negative 1 over 6, we get 1.97917. Okay? And kay x sub 3, itong dalawa na yung gagamitin natin to this equation. And we should get negative 6 plus 0.9375 minus 1.97917 over 7, you get negative 1.00595. Again, get the absolute differences nito. So this is 0.1875, ito naman 0.22917, ito 0.00595, and so on and so forth. You just continue this until we reach yung gusto nating number of iterations, or we get a very low error na. Okay, yung tolerance natin for that error. As you can see, diba sa Jacobi, if you recall, hanggang 10 iterations inabot, tapos medyo mas malaki pa dito yung errors na nakukuha. This time, 7 iterations pa lang, medyo malapit na siya dun sa accurate or sa true or sa exact value ng ating variables x sub 1, x sub 2, and x sub 3, or in our solutions to the linear system. Okay, so yeah, halos same lang naman yung nakuha value, negative 1, 2, and negative 1 respectively. So yeah, as you can see, dahil nga gumagamit na tayo ng latest values ng mga unknown variables natin, mas bumibilis yung pag-converge niya sa solution. Okay, so that's our Gauss-Seidel method. You can actually improve pa yan using the SOR method, or yung successive over-relaxation method. Improve siya, okay? We just write yung pinaka-equation niya. Improve Gauss-Seidel method lang talaga siya kasi as you can see, same na same to dun sa sa second equation ng Gauss-Seidel method, di ba? Yung relationship between the current and your previous iteration, and considering this as your residual. Okay, so instead of 1, meron tayo ditong omega. Diba? Sa Gauss-Seidel, yung omega na yun, or yung over-relaxation factor na yan, giging 1, diba? 1 yung nandun sa equation natin for the Gauss-Seidel method. Okay, yung over-relaxation factor na yan, para maging improve yung Gauss-Seidel method natin, kailangan between 1 and 2 siya. Okay? Para ma-ensure natin yung system is over-relaxed. So, yan yung gusto natin. Bakit? Kasi kapag nakapili tayo ng value or accurate value, an optimum value for that omega between 1 and 2, pwede pang maging mas mabilis yung iteration natin or yung convergence natin. Okay? 'Di ba? Kung kanina sa Gauss Seidel, 7 iterations, malay mo kapag napili mo yung, yung optimum value ng omega, baka 5 iterations lang, tapos na. 'Di ba? So, that's what we want. Pag less than 1, under-relax na siya. And pag greater than 2, yung method natin will diverge or di tayo makakuha ng solution. So, ito yung gusto natin, yung over-relax. Kaya nga sa tinawag na successive over-relaxation method. Pero paano kinukuha yung omega na yan? Yung optimum value ng omega na yan? Actually, there's a way to compute that, pero it's not covered in our course, so I will not be discussing it. If you want to know more about it, you can just read it from our textbook. Okay? So, yeah, that's all for our iterative solutions for linear systems. Alright? So, sa ating next content, I will be discussing yung eigenvalue algorithms. So, for now, thank you muna for listening and goodbye.